Fourth grade lesson 5.6 is number patterns. Recognizing number patterns, various patterns in your numbers, is going to help you a lot as you work ahead in your math. Especially when we get into the algebra portions, recognizing patterns is really helpful. And so this lesson helps us recognize patterns by creating patterns and seeing how those work out. So let's have a look. So our essential question on this is, how can you make and describe patterns? We'll unlock the problem. Daryl is making a pattern for a quilt. The pattern shows 40 squares, and here are the 40 squares that it shows, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 to 40. Every fourth square is blue. How many blue squares are in the pattern? They want us to find out how many, oops, that's not a good color, how many blue squares are in the pattern. And they said every fourth square is blue, multiples of 4, right? So we'll go through with blue highlight, a blue highlighter or a blue crayon or whatever you have, and we're going to go ahead and go through. The pattern is an ordered set of numbers or objects. It's the way that something goes in an order, and you recognize that it's going to continue in that pattern. Multiplication is a pattern. It's counting by certain numbers. Each number or object of the pattern is called a term. All right, so we're going to go ahead. They wanted every fourth square, and they already did 4 for us. So we did 1, 2, 3, 4, 5, 6, 7, 8, right? This is multiples of, multiples of 4. 8, 9, 10, 11, 12, multiples of 4. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. There's our pattern, multiples of 4. Which squares are blue? Well, the squares that are blue are all the ones that are multiples of 4, right? And how many blue squares are in the pattern? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And of course, we know that 40 divided by 4, multiples of 4, 40 divided by 4 is going to equal 10. So you can see how that related. What pattern do you see in the arrangement of blue squares? Okay, well, we can look at it and see different types of patterns. One pattern I see is there's 2 in this row, and then 1, 2, 3, and then 2 and 3. So a 2, 3, 2, 3 pattern, right? 2 blue ones, 1, 2, 3 blue ones, 2 blue ones, 3 ones. So we can say a 2, 3 pattern. Meaning we see 2 in each row, 2 and then 3 and then 2 and then 3. I could go this way and I have 0, 2, 0, 2, 0, 2, 0, 2, 0, 2. I hope I'm making sense like that. There's no blue ones here, there's 2 blue ones. No blue ones here, 2 blue ones. No blue ones here, 2 blue ones. So maybe you noticed a 0, 2 pattern or a 0, 2 pattern. Those are 2 patterns that stood out to me. Patterns are just like a repeated thing that you start to notice. And so there's 2 patterns that I noticed. Maybe you saw something else. And what pattern do you see in the numbers? 4, 8, 12, 16, 20, right? We already noticed it was multiples of 4. They're multiples of 4 is what I notice. My brain is in multiplication mode, so that's what I'm noticing first. Let's look at this example. It wants us to find and describe a pattern. The rule for the pattern is to add 5. So the first term, this, will be in the pattern will be 5. So we 5 and then we add 5, that's 10. If we add 5 to 10, it's going to be, right, 15. And then we add 5 more, 20. And you know that repeated addition is going to give you those multiples of 5, 25, 30, and then add 5 more, 35. So our pattern is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, and on, right? What do you notice about the digits in the ones place? Well, let's take a look at the digits in the ones place. There's a 5 and a 0, and 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 a 5. That's probably going to be and a 0 and a 5 and a 0, right? The pattern is they are 5s and 0s. And they're fives and zeros alternating. There, I wrote that more clearly. Alternating. It was messy. Sorry about that. All right. Describe the pattern using words odd and even. Oh, okay. So remember, for odd numbers, they're any number that ends in 1, 3, 5, 7, and 9. And evens end in 0, 2, 4, 6, or 8. So I have a 5, that's odd, and a 0, even. Odd, even, odd, even, odd, even, odd, even. So we're alternating odd to even, back and forth. Odd, even, odd, even, odd, even, odd, even. So there's another pattern. Describe the pattern using the word multiples. These are multiples of what number? If I'm whatever number I'm counting by, and we were increasing by 5, right? So the terms are multiples of 5, 5, 10, 15, 20, 25, 30, 35, 40, 45, and on and on. Those are all multiples of 5. So we will put multiples. They are multiples of 5. So those are different patterns that you might notice with this set of numbers. Okay, they gave us this challenge as a bit of a challenge. Let me make it bigger here. The rule for this pattern is to add 3 and then subtract 1. The first term in the pattern is 6. So we start with the 6 because they said the first term in the pattern is the 6. And then they want us to do a pattern of adding 3 and subtracting 1. So we will add 3. So 6 plus 3 is 9. Then subtract 1. So 9 minus 1 is 8. Very good. Then we will add 3. So we're going to go add 3, subtract 1. Add 3, subtract 1. Okay, so add to 8. We'll add 3. So 8, 9, 10, 11. Then subtract 1. 11 minus 1 is 10. That's right. Add 3. So 10 plus 3, 13. Subtract 1. 13 minus 1, 12. Add 3, 12 plus 3, 13, 14, 15. Subtract 1, 15 minus 1, 14. And finally, add 3, 14 plus 3, 15, 16, 17. Describe another pattern in the numbers. So I'm going to look through these numbers and see if I notice anything happening. One thing I think I'm noticing is I have even, odd, even, odd, even, odd, even, odd, even, odd. That's one pattern you might write down, that they're alternating between even and odd numbers. Every time, let's look at just my even numbers. Here's another pattern. It was 6, and then my next even number is 8. That's 2 more. And then my next even number is 10. And then my next even number is 12. And then my next even number is 14. So all of my even numbers are going up by 2 each time. That's something I notice. What happens with my odd numbers? 9, 10, 11, 12, 13, 14, 15. So same with my odd numbers. They go up by 2. Every odd number continues up by 2. That's another pattern you might notice. There's all kinds of patterns you might notice. As long as you see the same thing happening repeatedly, you can put it here. I'll put down that the numbers alternate between even and odd as they go up. But maybe you noticed something else as a pattern that you can write there. So you don't have to have the exact same answer I have here. If you noticed another pattern, something that you noticed repeatedly happening, you could put that. So let's look at the Sharon Show and see how we can answer these questions. If you feel like you're ready to go to the Think Central or the On Your Own. They want us to use the rule to write the numbers in the pattern. So they're going to give us a rule, and then we'll write the numbers. The rule they're giving us is that we're subtracting 10. The term we're starting with, it was 100, and we subtract 10. So 100 minus 10, subtract 10. 100 minus 10 is going to be 90. Very good. And then we continue doing that, subtract 10 again, 90 minus 10, 80. 80 minus 10, 70. 70 minus 10 is 60. So the terms we end up with were 100, 90, 80, 70, 60. If we continue, it would be 50, 40, 30, 20, 10, and 0. So that's the pattern we'd end up with this rule. First term was 100. Use the rule to write the number in the pattern and describe another pattern that you see in the numbers. Okay, well, the rule is to multiply by 2 starting with our first term of 4. So here's 4, first term, 4. Multiply that by 2 to get this. So 4 times 2 is 8. Good. 8 times 2 is 16. 16 times 2, ooh, okay, I don't know my 16s off the top of my head, so 2 times 6 is 32. 2 times 1 is 2, 3, 4, 5. 52. 52 multiplied by 2, okay, back to the math lab, off to the side over here to do my experiment. 2 times 2 is 4, 2 times 5 is 10, 104. That's starting to climb up fast, right? Those numbers increased fast. What other pattern do I see in the numbers? Let's see. Well, I do notice that they're all even numbers. Here's something else I noticed. Single digit, double digit, triple digit. I don't know if the next one would be a quadruple digit after that, though. That's just the initial pattern I'm seeing. I don't know if that's going to continue, so I don't know if I'll go with that one. I'm just going to say that they go in evens. Or maybe that each number doubles. Everything doubles. 4 doubles to 8, 8 doubles to 16, 16 doubles to 52, 52 doubles to 104, which is really the meaning of multiply by 4. I'll go with that. Each number is double the one before it. Okay, one more pattern to recognize. We're going to skip count by 6. So skip counting is just counting by that number, 6, 12, 18, 24, right? But our first term is going to be 12. So starting at 12, skip counting by 6. So if I were skip counting by 6, I go 6, 12, 18, add 6 more is 24, add 6 more, 25, 26, 27, 28, 29, 30. Add 6 more, 36. So that's what I get. What is another pattern I might see? They're all multiples of 6. I suppose that's a pattern I see. They're all even numbers. I was looking at, I saw 1, 1, 2, 3, 3. I don't know if it would be 4, 5, 5, 6. I don't know for the first digit. I don't know if it would continue that way. So I'm not going to use that one because I'm not sure it would continue that way. Let me look at the ones place. 2, 8, 4, 0, 6. No, I don't see anything standing out to me as a pattern there. I don't know. I suppose if I pondered long enough, I could find some other ones. But the one that stood out to me first is they're all even numbers. So just in the interest of time, I'm going to go with that. They're all even numbers. That's a pattern I recognize there. They're all multiples of 3, right? Also multiples of 6. So anyway, that's all this is just creating the patterns, recognizing the vocabulary of the rule that you're using, the term that you're starting with, creating the pattern, because if you create patterns and you get used to doing that, then you're going to be better at recognizing them later, and then just recognizing what's going on. I am going to look at number 6 with you, so that you can see this happening from a word problem perspective. So Marcy likes to collect stickers, but she also likes to give them away because she's generous, you know. Currently, Marcy has 87 stickers in her collection. That's the term we're going to be starting with. I'm going to go ahead and write that down. 87 is what she currently has. That's our starting point. If she collects 5 new stickers each week and gives away 3 stickers each week, how many stickers will Marcy have in her collection after 5 weeks? Okay, so 1 week. There's 2 things that happen in each week though, right? She adds 5 and then takes 3 away. So I'm going to put 2 bars for each week. 1 week, 2 weeks, 3 weeks, 4 weeks. I should have given myself more room. 5 weeks. I'll put it down there. Okay, starting at 87, remember where she gets 5 more. Let me circle that, 5 more. So I will add 5, and then from that I will give away 3. So I'll subtract 3. So my pattern is going to be an add 5, take away 3. Add 5, take away 3. So 87 will add 5, 88, 89, 90, 91, 92, 93, and then take away 3. 93 minus 3, oh, that was nice and easy, 90. And then add, now we just go to that pattern again. So this was the first week. And then we're going to add 5, 90 plus 5, 95. And subtract 3. 95 minus 3 is 92. You're right. This is the second week. And then we will add 5 again and take away 3. So add 5. 92 plus 5 is 97. And then take away 3. 97 is 96, 95, 94 for the third week. 94, add 5, 95, 96, 97, and 8, 99. And take away 3, 99 minus 3 is 98, 97, 96 for the fourth week. And finally for the fifth week that I had to put down here because I couldn't fit, 96 plus 5 is going to be 101. And then take away 3, 100, 99, 98 for the fifth week. And so once I finish the pattern after the fifth week, we end up, how many stickers will she have in her collection after 5 weeks? She will have 98 stickers. So we needed some room to work that out, right? We needed to kind of plot this out. This is the same thing we've always been doing. Draw those pictures out. And we started at 87, add 5, subtract 3 for the first week, add 5, subtract 3 for the second week, add 5, subtract 3 for the third week. So we just had to lay out the pattern. So if you get a question like this in Think Central, your numbers might be different, but at least now you see how to iron this thing out, how to figure it out.